Before we begin talking about preferences, let's just quickly review the two goods model. We have two goods that we call good 1 and good 2. We consider a single point in time and a single individual, and she needs to decide how much to consume of these goods. We use the symbols x1 for the quantity consumed of good 1 and x2 for the quantity consumed of good 2. Consumption cannot be negative, which requires x1 and x2 to be greater than or equal to 0. Both goods are infinitely divisible, meaning that x1 and x2 can take any non-negative real number. The price of good 1 is denoted by P1 and the price of good 2 is denoted by P2. Both prices are strictly positive and fixed. The consumer has a strictly positive income denoted by M. The consumer now needs to decide on how much to consume of each good. In the previous lectures, we have looked at the restrictions she faces. Her total expenditure may not exceed her income. We define the equation of the budget line as the equation P1x1 plus P2x2 is equal to M, and we define the budget line as the collection of bundles satisfying the equation of the budget line. What we will do now is to introduce preferences over these goods. So here's the basic idea. Say that good 1 is cookies while good 2 is milk. Think of the consumer facing two different bundles of these two goods. Each bundle will have a certain amount of each of these two goods. Perhaps our first bundle has 8 cookies and 6 glasses of milk, while our second bundle has 4 cookies and 9 glasses of milk. Our key assumption will be that the consumer will be able to declare which one of them she prefers, no matter what the composition is of these bundles. The first thing we will do is to introduce symbols, so-called preference symbols, which we will use to describe our preferences regarding these two bundles. So let's go back to general notation. The first bundle will contain x1 units of good 1 and x2 units of good 2. The second bundle will contain y1 units of good 1 and y2 units of good 2. We use x's referring to the first bundle and y's for the second bundle. And sometimes we call the first bundle the X bundle and the second bundle the Y bundle. We use subscript 1 for the first good and subscript 2 for the second good. All 4 variables x1, x2, y1 and y2 can take any value that is not negative. The consumer is now facing these two bundles. Let's say that she strictly prefers the first bundle to the second. We will use the following notation to describe this scenario. We write our first bundle x1, x2, followed by this funky looking greater than sign, followed by the second bundle. We can revert this symbol and use the following notation to describe the case when the second bundle is strictly preferred to the first one. It may also be the case that she does not strictly prefer any of the bundles. We then say that the consumer is indifferent between the bundles, and we use this little wiggle sign. The consumer is equally happy no matter which of these two bundles she receives. If it is the case that she either strictly prefers the first bundle or she's indifferent between the bundles, then we say that the consumer weakly prefers the first bundle to the second. You can view this as the exact opposite to the second case. It is false that the consumer strictly prefers the second bundle to the first. If the consumer declares that she weakly prefers the first bundle to the second, we will not know if she strictly prefers it or if she is indifferent between the two bundles. Similarly, the curvy less than or equal to symbol is used when the consumer weakly prefers the second bundle to the first. So this is where we are right now. We should be able to present any two bundles to the individual that is about to make the consumption decision. And for each of these 5 comparisons, the individual should be able to tell us if it's true or false. What we need to do next is to make some reasonable assumptions on preferences in order to avoid ending up with contradictory or really strange conclusions. For example, suppose that we present 2 bundles to a consumer. We then really want to avoid having to analyze a situation where she claims that both the first and the second statement is true. It turns out that the assumption we need to avoid such weirdness can be stated quite elegantly using the mathematical concept total order. Once introduced, we will always assume that preferences are a total order, in which case, for example, the second statement must be false if the first statement is true. In order to better understand the concept total order, we will first look at another simpler comparison, which is also a total order, namely the greater than or equal to symbol comparing two real numbers.